What is up? Daniel here with the Virtual Robotics Studio, and we are back for autonomous mode programming. So we did teleop, we have driver control where we use the game pads, but now we have to take care of the first 15 seconds of the match that is pre-programmed. As always, special thanks to Argosy and Everybot. Okay, so we've got the robot out. Make sure you have a battery in your robot. Make sure it's powered up. You're going to need a couple of other things. I've got some tape and a tape measure and a Sharpie to mark the tape. So if you are lucky and you can access a full field or have enough space where you have part of a field built up, then you already have the lines and the marks and stuff there. But we don't have that in this room, and we want to get our auto mode as close as we can get it before we head over down the hall, across the school to where we can get access to a field. So what I'm going to do here is I'm going to actually get some tape marks on the ground and say this is where the goal would be, where the grid would be starting. This is where the tape line at the end of the community would be, so we know how far we would have to drive to get out of the community to get the mobility points. And then we probably will ignore the charge station, but if you were working on a charge station auto, you could also kind of tape out where the charge station would be, just so you know you got to drive about this far. And then when you do get to a field, your code's already mostly there, and you're just dialing it in. Okay, so first, let's go back to Visual Studio here on our laptops or computers, whatever you're using. And we need to reopen the code. Now, if you're lucky, you probably just open Visual Studio and it remembers the code that you had up last time and you're good to go. If not, just a reminder, you can do File and you choose Open Folder. Open Folder is the way to do it. And mine is on the desktop, 2023 FRC code, 2023 FRC code. I guess I have two folders named the same thing. That's fine. Select Folder. And you'll know it's right because it's going to pop up. It has the robot.java with all the stuff we did last time. Main.java and our vendor dependencies that we added, Phoenix and RevLib. So that's how we reopen it. The next thing we're going to look at is, this is the best diagram I could kind of find of the field. Now, it is missing some of the key dimensions that we would care about. So the first thing is we care about if we start, I guess for our robot, there's a chance we're going to start here, either in front of the cube or here in front of the cone. Either way, our robot is going to have to back up across this line. So the dimension from the front of this line here to the back of this line here is actually, I believe it's 76 inches. 76 inches, or that's what, 6 1/3 feet. So if we start on this short side of the field, we need our robot to be able to back up 6 1/3 feet plus some margin, so maybe we want to back up like 7 or 8 feet. We do know this is 224 inches to the game pieces here. These are 224 pieces away from where we would start. So we don't ideally want to hit the game piece. So we want to move sort of across this line, but not into that game piece. Then it is possible that we're going to start on the other side of the field, and then we would have to back up farther. So you just have to be ready. You might need a different auto mode for the short side of the field versus the long side of the field. And you might have to start in the middle and back up over the charge station. That we're not going to worry about today. That's something you're going to have to add on your own. I think right now it's safer for this robot to start on one of the sides. Okay, but this long side down here, the dimension from the blue line to the blue line is actually 100 and it's like 139 inches. It's just under 139 inches, which is 11 feet and I don't know, or 11.5 feet, 11.6 feet. Something like that. So that is a much bigger distance that we'll have to drive. So what I'm going to do now is I'm going to head over to where my robot's parked. We're going to put some tape marks on the field, and then we can have our starting zone, which is going to be that blue line here, and then we can have our target zones where the short community line is and the long one is. So that is from the front of the robot, and I do so happen to have blue tape, which is cool. And I'm going to set this down. I'm just going to set a line down in front of the robot over here. And I think, let me make sure I have room for this to move out. I think we do. This will clear from here. So this is going to be my starting position. There is the blue tape line for that. And then if I go from there, if I come back 76 inches, and it is from actually the front of the tape, so the tape is part of the zone, is part of the community. So I'm going to work my way back here. And I'm looking first for 76 inches. So this is the close tape line. So I got 76 inches right here. And that was, the 76 is to the back of this tape line. So that, once you are, the tape is in the community, I believe. So you got to get all the way past that tape line. And then the second one was like 11.6 feet. I think it was like 139 inches. So there we go, 139. We'll get another piece of tape here. Okay, that looks good. So we're kind of set up now to be able to test our robot just driving different distances. We can even say, hey, if you're just starting it back at the line and you're only going to drive, then we can just move, I guess, we can pretend like there is one more line that's just right here at the back of the robot, because we would be starting inside the community, and if we clear that line, we would be good. And then we can practice driving if we have to go to the short spot, practice driving if we have to go to the long spot, and then we can also add in, hey, let's actually score a cube or a cone first, and then back up to get the mobility points. I think no matter what you do, you want to get those mobility points. OK, so let's load our code up. In our first auto mode, you know what? Just to get some practice here, we're just going to do a move auto mode. And we're just going to try to move about 3 feet to get the robot across the line. So if you parked with your robot right on the line and you drove 3 feet, you would get your points, your mobility points. And let's go backwards for this too, because when we actually get to the harder ones where we're scoring first and then you're going to be backing up. So we might as well always go in that direction. So in the code, let's go to robot.java if you're not already there. And let's start at the very top of everything. And there's a few more things we have to add. So the first thing is we're going to add one more import up here. So underneath all of the WPI live imports, so underneath joystick is where I'm going to put it because it's another WPI live import. We're going to import edu.wpi.first.wpi live. And this one is going to be called timer with a capital T. And what timer does is timer is going to let us basically measure how much time has passed in seconds. So we can tell our robot to back up for a certain number of seconds. Again, remember the yellow squiggly just means, hey, you haven't used this yet. You imported something and you're not using it. That's fine. We'll fix that later. OK, then down here, underneath the public class robot extends timed robot. This is where we can label our different auto modes that we're going to create. And this also will create a chooser, which we saw in that smart dashboard, right, where you could choose between default and my auto. So here's the thing, though. Our default auto, we're not going to have a default auto. So we're going to change kDefault auto to be k nothing auto. And instead of default, we're going to say nothing. This means do nothing, right? So we have an auto mode that does literally nothing. You could even say, you could have it say do nothing instead of just nothing. That's fine. Maybe no capitals, because then we don't have to worry about capitals later. It doesn't really matter. All right, so we have a do nothing auto mode. And then the second one, which is called k custom auto right now, we're going to change that. This is going to be our k move only auto mode. So there is no scoring of game pieces first. We're just driving across the line. So this is going to be move only. And basically, we're saying now we can say k nothing auto, and it has this do nothing string. Then we're going to be able to pass this do nothing string to the chooser on the smart dashboard, so you'll see that name on the dashboard when you're picking stuff. All right, and we're actually going to have some more here. So let's create them now, so we don't have to worry about it later. So hit enter. We're going to basically copy the line of code above this. We're going to do another private static final string. And this one is going to be k cone, which is going to be equal to cone auto, and get a semicolon at the end of that line. And then, of course, we're going to do another one that is private static final string k cube equals, and I quote, cube, with a semicolon at the end of it. OK, so now we have, I think, all of our different potential auto modes in that we're going to worry about. If you wanted to, oh, string needs to be capitalized. Let's get that capital S in there. All right, if you want to add more auto modes, you would add them in here to choose from. OK, and we don't have to change any of that stuff. So now we are ready to move down on our code. And what we're looking for now is robotInit. Find robotInit. And this is where stuff is getting sent to that chooser. So this is where it gets sent to the smart dashboard, and we have the options. So we have set default option, which is right now we don't have a K default auto, right? So this should be called K nothing auto. So our default, if we don't put anything in to do differently, is don't move, which is probably the safest option, right? And this is what's going to show up on our smart dashboard. So this one should be do nothing. Okay, then we're going to add options. So we created a default option. We're going to add more options. So our more options is not my auto, but move only. And that should be K. I think we said move auto, right? We're going to type move in, and if it doesn't find it, then we'll know it was wrong. Might be wrong. K move only is what we called it. K move only. Okay, and then what do we call we just called the other ones K cone and K cube. I guess we probably should add auto at the end of those, but it's still just a name, so it doesn't matter. Let's do another m.chooser.add option. And this one is going to be K cube. Let's see, we want to get rid of this though. And we're going to do quotes on the front. And inside the quotes, this is going to be, let's see, I guess this is going to be cube and mobility, because we're also going to move. And then you do a comma in between them, and that is K cube. All right, and let's copy this because we have that last option. Enter, paste that in. This one is going to be K cone. And instead of saying cube and mobility, it should say cone and mobility. So those are the 4 auto modes we were talking about. Now we created them. We have put them into the smart chooser, so they'll show up on the dashboard so we can actually select them and run them. And now I think we're ready to actually get started making them do stuff. So let's scroll down. And what we are looking for is, I guess we're looking for robotPeriodic. And this is just the way that, well, you know what? Let's skip that. Let's skip that. We don't need that for right now. We're looking for autonomousInit. Sorry, we're going to go down to autonomousInit. Okay, and in autonomousInit right now, it tells us what auto mode we've selected. It's going to print that out. That's cool. And it does that by getting the selected auto. So this line here, m auto selected equals m_chooser.getSelected. This is basically reaching out to the smart dashboard, saying which of the radio buttons did you click, which auto mode did you click, and save that value in m auto selected. And then it's going to print it out, so it will let you know that it is actually selecting the one that you think it was selecting. OK. And what we have to do here, though, is we're going to do a few things to set stuff up. The first thing is, we talked about how when we started teleop-init, we took all of our drives and we set them to coast. In auto mode, though, we want them to be break, not coast, so that we don't keep rolling, so that we stop pretty much exactly where we wanted to stop. We can do this in auto because we're going to be driving very slowly, so that it's not going to be like we go fast and then stop, and the robot's going to be tippy and unstable. So actually, if you scroll down to find void teleop-init, these 4 lines right here, drive left spark, drive right spark, drive left Victor, drive right Victor. Let's just copy those. Just go ahead and hit the copy. And then we're going to go back up to autonomousInit underneath that system out and just paste them in. And what we're going to do is we're going to change all of these K coasts to K break. Well, OK, we're going to change the first 2 K coasts to K break. The second 2, which are just coast, we're just going to change to break. And remember to tab complete or enter complete, because then you don't have to worry about spelling mistakes. And you don't have to worry about getting confused as to whether it should be K break or break. It knows the answers. OK, then there's one more thing we want to do in autonomousInit. Actually, there's several more things we want to do in autonomousInit, but we'll get there. OK, so the other thing we have to do is we have to get our timer going. And the timer works a little bit, it's a little bit weird. the way that the timer works is basically when you turn the robot on, it starts counting up. And it starts counting up in like microseconds or milliseconds. It doesn't matter. It's some it counts faster than we can count. And so it has this stopwatch that's running as soon as you turn the robot on. But what we actually care about is when autonomous mode starts, that's our 0 time, right? Because once autonomous mode starts and we start driving, we really want to move like for 3 seconds from that point. So what we actually have to do in the code now is we have to figure out what time was on the stopwatch when autonomous mode started, and then we can look at the current time while autonomous is running, subtract the two, or subtract the start time from the current time, and that will give us our elapsed time. And that elapsed time is what we're going to build everything from. So we're going to try to make that pretty simple, but in order to do that, we have to create a couple variables. So if we go above autonomousInit here, I guess there's all this green stuff, so I'm going to go above the green stuff too. Kind of too much green stuff here, but what we need to do is we need to create, I guess we're going to create 2 variables. We're going to start with just one, though. So double, and it is going to be auto start time. This is, again, that time on the stopwatch when autonomous mode started. Then, in autonomousInit, what we can do is we can say, hey, auto start time is equal to, and it's timer dot, right? So we added that timer, we imported timer so we could use it. And it's timer.getFPGA timestamp. That is the stopwatch value of since the robot started. I'm going to put a semicolon there. OK, so now we know when autonomous mode started. Now we're ready to move into autonomousPeriodic. And again, remember, autonomousInit runs one time when autonomous starts. So resetting our stopwatch or getting the start time on the stopwatch is perfect to do right then. All right, now in autonomousPeriodic, there is this switch here. Yeah, let's get rid of this. So basically, all of this from switch down to the close curly brace here, we're going to delete. So the only thing you should have is open curly brace, closed curly brace. And we'll probably do the same thing, but we're just going to do it with a couple if statements. So the first thing is, hey, if. And remember, we have our auto mode, which is m_auto selected, right? That gets the value of what auto mode we chose to run. And the question is that equals to? Because we're checking it, we're not changing the value. Remember, a single equals is when you want to put a value into something. Double equals is when you want to compare it to something. And the question is m_auto selected rk nothing auto? Is it? Because if it is, guess what? We do nothing. And if we're going to do nothing, well, nothing is basically, we can do set, remember set drive? We have set drive motors. And set drive motors wanted, it definitely did not want arm current limit. Set drive motors wanted our forward value, comma, our turn value. See this thing that pops up? It wants our forward value and our turning values. But if we're doing nothing in auto, those values are both zeros. So it's going to be 0.0, comma, 0.0. And probably you don't have to put this here, because generally speaking, the motors will remember to stay off if they were off. But this is the safest way to make sure nothing happens in our nothing auto. So we had drive motors. Remember, we also have set arm motor. And that wants a percent value for what it should be doing. And 0.0 is the percent value of what we want it to do, nothing. And then we also have set intake motor. And this one wanted percent and an amp limit. So you know what? 0.0 for the percent. We definitely don't want to move. The amp limit can be our normal amp limit, which if you remember was intake underscore current limit A. It doesn't really matter, again, because it's not going to move. You could put a 0 here and say the current limit is 0, and it should be fine. All right, guess what? We wrote our first auto mode, which is literally sit here and don't move. All right, let's try to do a little bit better than that. Now, we did the if, and we looked for nothing. Now we're going to do an else if. And this time, we're going to look to see if the selected auto mode, m_auto selected, we're going to see if that equals, right? If that is k move only. If it is, what are we going to do? Well, we're going to move. And for this one, we need our time value. And we need not just the time when auto mode started, but we need the actual elapsed time on the stopwatch. So this autonomous periodic loop, right, runs it over and over and over again while we're in auto mode. And so what we can do is if we go up above, I want this to be the very first line in autonomous periodic, okay? The very first line is going to be, hey, let's get our elapsed time. And it's going to be a double. We're going to call it elapsed time. And we're going to make it equal to, and remember I said if we get the current time, which is timer.getFPGA timestamp, that is the current time on the stopwatch, and we subtract from that the time when auto mode started, we will have our elapsed time for auto mode, the amount of time that has passed in auto mode. And we saved that value right up here as auto start time. We have timer.getFPGA timestamp, and so if we subtract auto start time from it, that is our elapsed time. So now that will tell us how long we have been in autonomous mode. Now down here, we have basically two different possibilities for our move-only auto mode. Possibility number one, we should be moving because we haven't moved for long enough yet. Possibility number two, we moved long enough, we should not be moving anymore. So what we're going to do is we're going to check and we're going to see, based on how much time has passed, what we should do. So if we say if, and then your parentheses, what we're looking for is if our elapsed time, okay, if our elapsed time is less than something, then that means we haven't driven long enough. And let's just put a number in here for right now. Like how long do you think we have to drive for our move only to just get across the line and do nothing else? Well, I don't know. Let's drive for 2 seconds. I'm going to put 2.0. Okay, and if that's the case, we're going to do the open curly brace. So if our elapsed time is less than 2 seconds, we should be backing up. So we're going to do a set drive motors, and we need a negative speed. And I said we're going to go slow. We're going to go slow. Like we have 15 seconds and we have to drive 3 feet. There's no reason to go fast. So we're going to go minus 0.25 for our power. Negative 0.25 because we want to go backwards. And then the next thing that it wanted is our turn value. We don't want to turn at all. We want to go straight backwards, so that's going to be a 0.0. All right, then just to be safe, the right thing to do is if you look up here in our do nothing auto, we have this set arm motor and set intake motor, and that turns off our arm and our intake. And so we're going to want both of those to be in here as well. So I'm going to copy those 2 lines of code, and I'm going to put them right underneath the set drive motors, because we never want the arm to move in this auto mode. All right, then, if that elapsed time has passed, right, if it's been more than 2 seconds, then we're going to have an else case. So first it checks if elapsed time is less than 2 seconds, we're going to slowly drive backwards. Otherwise, once more than 2 seconds have passed, or 2 seconds or more have passed, then we are just going to stop. We're not going to move at all. And guess what? That is the same as our do nothing auto. So let's select all 3 of these lines, paste them in the else case, and now we are basically going to do nothing at that point. All right, I think we can test this. Let's try. Let's try. So we're going to hit the 3 dots. We are going to build the robot code. And once it is done building, we'll see. It's taken a second. There we go. Then we'll hit the 3 dots and choose deploy robot code. Another thing to keep in mind is, remember, auto mode is the first thing that happens in a match. So you will almost always have a brand new battery. So when you're doing the testing here, you probably also want to make sure your battery stays fairly highly charged. Okay, I cannot see the robot. Once again, I have all this like failed to find the robot, failed to find the robot. Guess what? Probably I didn't connect to the wireless network, because that's almost always what it is. I can see that I am in fact not connected to the wireless network. There is the one I want to be connected to. Now I'm connected to it. Let's just do this too. If you run your driver station, because we're going to need that anyway. So I'm going to say yes, it's going to run the driver station. And we have our smart dashboard popping up, so that's good. Now I can see I have communications and code. I have no joysticks, but guess what? I don't I don't think I need any joysticks because we are doing auto mode. So you can plug yours in if you wanted to, but we don't need them right now. All right, now hit the 3 dots, and I will deploy robot code again. And this time, it should actually download it, or it should actually deploy it. That looks better. OK, build successful. All right, let's open this stuff up now. All right, and we have a problem that our smart chooser window is not here. Let's reset the live window. OK, that is not helping. Let me close this. We'll open it up again. And we will see if... So I will click to default. So on the gear thing, I'm going to switch to default. Then I'm going to close that, and I'm going to switch back to... Oh, and it always asks about this. Cancel. OK, and I'm going to switch back to the smart dashboard. There we go. Now it's back. So if your thing, after you've changed stuff, is not there, you basically have to switch to nothing maybe, switch to remote and switch back, because then I think you don't get the default like pop-up menu. That's a problem. And right, we want this kind of front and center so we don't forget it. And there are our options. So first, we can not be editable anymore. And you actually have to not be editable if you want to select something. So that is Control-E or click View and Editable. And we can choose from the different auto modes. First, I'm going to choose Do Nothing. And then down here on our driver station, go back to the steering wheel. And we're going to choose autonomous mode here. And I'm going to go ahead and enable. And nothing should happen. Nothing happened. Excellent. So you can see the robot, it didn't move. Still where it started. No robot, no motors going, nothing changed. Good. So we'll disable now. And now let's try our move only auto. So once again, on the smart dashboard, we have the different choices here. And we're going to click on move only. OK, so make sure you highlight move only. And then we're going back down to our driver station, and we're going to choose enable. And it should drive backwards a little bit for 2 seconds. OK, guess what? 2 seconds is almost the perfect. This is almost the perfect amount to cross this line over here. So this is actually, heck, that's good. I'm down with that. That's perfect. It actually, OK, maybe it's a little close. Maybe we want to go slightly farther. But great. I'm going to disable the robot. And then rule number 1 of autonomous, the most important rule is your robot must start in exactly the same place, facing exactly the same direction if you want to be able to like adjust your code and have the results make sense. If the robot just keeps starting in different places, like if I start the robot 6 inches farther forward and then I tell it to drive a little bit farther forward, it's going to drive a lot forward. So always exactly the same place, same angle. Right now we're just driving straight, so the angle doesn't matter too much. And I found a wing nut that was probably an extra one I left inside the robot. All right. So that's working, actually. And as a move-only auto, that's fine. I think we're good with that as our move-only auto. So you can know that you can park the robot all the way up at the front, and it should clear the line on the short side. But also, if you're only moving, you can choose where to start the robot inside the community zone. So we could start, if we think it's a little too close, we could just start here. And it would drive past the line plus the few inches that I pulled it forward. All right. So we're back on the line. Let's say, let's make an adjustment, though. Let's say it's not good enough. Let's say we always want to start in the position like we were going to score something, and we wanted to get a little bit farther past that line in order to know that we were for sure like in a good spot. So let's go back to our code. What would we change to make it drive a little bit farther? Kind of like surprised that we guessed such a good number on the first try. So the only thing we have to change, we don't ever really want to change the speed because our whole autonomous plan is that we don't have a lot to do. We have 15 seconds to do it in. We're not going to rush. It's always going to move slowly. Slower is more accurate. It's more repeatable, and it's less scary. Bad things can happen to a robot if you try to go full speed in auto mode. So you need to make sure you know what's going to happen before you do that. So the only thing we want to change is right here, this elapsed time. we can make this elapsed time a little bit longer. So instead of 2 seconds, what if we drove forward for let's try 2.5 seconds. All right, so once again, we're going to build the robot code, and then we'll deploy it, and we'll see if we go just a little bit farther. So really, we should be going 25% farther, right? Because we're going for an extra 5.5 seconds out of 2 seconds. Okay, deploy the robot code, and we'll see if it worked or not. Okay, looks good. I'm going to close this extra window that keeps popping up because I don't care about it. I'm going to make sure move only is selected. And then we are going to go ahead and make sure autonomous is also selected. And then, yeah, let's run it. All right, so make sure it's in the right starting spot. And let's enable. Here we go. I would say that's pretty good, right? If we wanted to start there and make sure we were clearing the short side line, we're now clear of that line by about 2 feet, which is a solid margin for error. We could probably go back and say instead of 2.5, let's do 2.25 or something like that. You can dial that in. And just know that you can change this, right, for your robot if you want to be able to start on the other side and drive far. You can make a different auto mode that does that. Or you could adjust this one. All right, I'm going to pull it back and get back to the starting position. You will notice, too, by the way, as you move the robot, that brake mode makes it a lot harder to roll around than when the robot's off. That's good. We want that to happen. It is kind of annoying for resetting the robot, though. All right, I'm back at the start. And we're going to jump back into our code. And I think it's time now for us to take on one of our harder code things. So we have the K move only. Let's start our cone and our cube. And if we think about the cone and the cube, let's look at the robot. Let's think about what that means, right? So if we're doing the cone auto, we're going to extend the arm, spit the cone out, retract the arm, and then back up across the line. And probably this line, but maybe that line. If we're doing the cube auto, we're going to extend out, spit out the cube, retract the arm, and then back up over the line. So they're almost the same. And we can do a little trick here to, instead of making 2 more auto modes, the only difference between the two is whether we need to be spitting out a cone or a cube. So the direction of our intake is the only thing that changes. So I think we can set it up so that we can just flip between them that way and only have 1 bit of code below it. And that will also let us kind of only have 1 section of code to debug for both auto modes, which is pretty nice. But know that if you wanted to make 2 separate ones, right in here after the else if, we're going to hit enter. So if you go to the end of else if, you can see how I'm at this curly bracket or curly brace. It's highlighting the one down here. So that is everything in that is this else if move only. So if we go below that, we can set up the next one, which can be else. And in this case, it could just be else because that's our only other auto mode. But if you wanted to set it up to be like else if, we could do then else if m selected equals cone. Then you could have another one that's else if m selected equals cube. But in this case, we'll just do the else, and we'll leave it at that. OK. And we have to do something before auto mode. Well, yeah, let's do it before auto mode starts. Let's go back. Sorry, let's go back up to autonomousInit. And actually, we're going to jump above autonomousInit, where we have our double auto start time. And the idea here is that what we can do is we can create a variable that is going to let us know which direction the intake should be running. So we're going to do a double, and we'll call it auto intake power. Power sounds good. Let me get a capital P, though. Auto intake power. Okay, then if we come down into autonomousInit, I guess I'll go below the auto start time equals timer, but it doesn't really matter. All of this code runs so fast that really the order, nothing relies on anything else in here, so the order doesn't really matter. Except the auto selected, the chooser get selected has to be first. Okay. because what we're going to do now is we're going to use that value to determine whether it should be rolling forwards to spit out a cone or backwards to spit out a cube. Or I actually don't know which way forward and which way backwards is. And basically, we'll just say, hey, if, let's find out what auto mode is selected, right? M underscore auto selected. If that equals, and what do we have? We had K cone. If that's K cone, then guess what? Our autonomous intake power, or auto intake power, is going to be set to, and I think it's just intake power. If we do intake output power. And we can double check that. If we scroll down to our teleoperated periodic, and here is the button number 1 was cube in and cone out. So this is what I'm saying. If we wanted to spit a cone out, then it would be positive intake output power. If we wanted to spit a cube out, it would be negative intake output power. So scrolling back up to where we have it set here, we're spitting out a cone. We're doing the cone auto, so we're spitting out a cone, so we want positive intake power. Cool. Let's get a semicolon at the end of that line. Then, if it's not that one, we need to change the power to be the other direction. So in this case, there's no really other options, so we could do an else. If you're going to add more options and you're going to need other intake powers, you might want to have an else if, but I think if it's not a cone, it's got to be a cube for us, right? So we're going to do else, and we're going to set auto intake power to be equal to negative intake output power with a semicolon at the end of the line. So now we can treat both of these auto modes as the same auto mode. We just use auto intake power instead of our intake output power, and we already flipped the sign when it was needed. So let's go back down to autonomous periodic, back down to our else case. This is where we are doing our cone. And we can make a note here, right? This is cone and cube / mobility autos. Both are the same because we set the direction of the intake in autoinit. And let's get started on it. So the first thing is the entire thing we're doing here is going to just be a big if, else, if, else, if, else, if, else, if. And it's going to basically be like, for the first 2 seconds on the stopwatch, do this. For the next 2 seconds on the stopwatch, do this. For the next 1 second on the stopwatch, do this. So we're going to just build this whole structure where we say, during this time, we do this. Once the time is past that, do the next thing. Once the time is past that, do the next thing. So it's all going to be if elapsed time is less than. And what we need to do is we need to figure out how much time does it take for our arm to extend out. So in this case, we're going to say, I don't know, let's guess. Let's just guess a random number. Let's say it takes 0.5 seconds for our arm to extend out. It feels like it moves pretty fast, right? Then, what should we be doing? Well, set drive motors should be 0.0 and 0.0 because we're not driving. We're just sitting there waiting for the arm to extend out. And set intake, I guess let's always do this in the same order. We're always going to do drive, then arm, then intake. So set arm motor. This one, yes, this one should be doing something. What should this one be doing? Well, we want it to move, and we want it to move at the arm speed that we always use, which was that, remember we made that up here at the beginning? Let me scroll up until I find it. Where are you at? Did I not scroll up far enough? There they are. Remember all these static finals where we created the values for this is how fast the arm should move, or the intake should move, this is how fast the arm should move, this is the arm current limit, and all that? Well, guess what? After we find a good value here, we're probably going to come up here and make all of our new parameters for the auto modes exist up here as well. But we're going to do it really quickly one time down here with just a number. So we're going to set our arm motor to, it is arm, I think, output power. And then finally, we are going to set our intake motor to 0.0. And I guess, again, this one should be intake current limit. It doesn't really matter again. When it's off, the current limit doesn't matter. But we might as well stick with the current limit that is related to that motor. OK, then we're not going to do the rest of our auto mode, right? The auto mode would be to extend out, spit out the cone or cube, retract the arm back in, and drive. We're not going to do all the pieces at once. We're going to do one piece at a time. When that piece works, we're going to move on and do the next piece. Because what can happen is, if you try to do all the steps at once, if your first step has to change a little bit, sometimes it affects the other steps, especially if you're driving more than just straight backwards. So we're going to always have the last case on every auto mode we make, the else case. Once we're past our last timer thing, it's always going to be just turn everything off. And we can do that by just stealing from the earlier ones, right? You can scroll up to find the K nothing auto, those 3 lines of code, where it turns everything off. Grab those 3 lines of code, throw that in this else case. And so now what we should do is we should move the arm for 0.5 seconds, and then we should stop. OK, let's try it. 3 dots and build. And then 3 dots and deploy. These safety glasses are very dusty. Probably does not affect anybody but me. All right, we're going to load up our thing. Now, what we have to do is we have to choose cube and mobility or cone and mobility. Doesn't really matter which one we choose right now, because all we're doing is moving the arm. So let's go ahead and choose cube and mobility first. And then make sure you're on autonomous, and we're going to enable it. And the arm should move for half a second when we do this. So here we go. 3, 2, 1, enabled. OK, that was a result. The arm moved. I'm going to disable the robot before I walk over to it. And I don't know. That was maybe, what, like halfway? Like the arm was doing what we wanted it to do. The robot did rock around a little bit. That's OK. But we did not make it far enough. Right? So we need to increase that time. Let me put this back in. And remember, brake mode is on, so I'm pushing gently. I'm not trying to really fight with it, but I am going to make sure it's all the way back in. And let's look back in our code now. So that number that we picked of 0.5 was not enough. Let's increase it. That felt like it was maybe halfway, right? So let's try 1 second, 1.0. And this is, unfortunately, how programming goes. We made the one change that we want to test, so we're going to hit the 3 dots. We're going to build robot code. And then we will wait, and we'll test it as soon as it finishes. All right, 3 dots. Let's deploy. All right, still on cube mobility, still on autonomous. Let's enable it and see if the arm gets all the way out. Yes. Yes, it did. OK, so we found a pretty good number. I'm going to disable the robot. Let's just make sure it's all the way out. It is. It is locked out fully. So that's perfect. OK, I'm going to slowly, again, push this back in. This is a situation, too, where if you had your gamepads plugged in, you could switch to tele-operated mode, and you could use the controllers to fold the arm back in. So I think when I walk over to my computer, I will probably plug those back in, because this is already getting a little tiring. All right, we are in. We're back at the starting line. Now, we are doing a cube and mobility. So the next step is going to be to spit the cube out. So I am going to take a cube, and you're going to have to learn to do this on your robot. But basically, when the robot is off and disabled, you are going to have to feed the cube in by hand. And I think the easiest way is to just kind of roll the rollers and suck it in. So now we have a cube in the robot. We are in the correct starting position. Let's come back to our code and see what we want to change. All right. So let's see. Let's actually start taking our numbers here, and let's start making them be kind of constants that we use in the program like we did before. So let's go up here and let's do // we're going to do autonomous mode constants. And they're all going to be static final. And the first one is going to be a double. And this is going to be our move. I guess this is going to be move underscore only underscore time. So for our move only auto, this is how long we should drive. And I think we ended up with that being at 2.5 seconds. And I can scroll down and look. So for our move only right here, we are going for 2.5 seconds. So that's good. And then our arm on our other one is 1 second. So that is the next one that we need. So we need to do a static final. And then this one also has to be a double, right? Because we want to be able to use decimals for it. So this is also a double. And what should we call this one? This is going to be like arm, all capitals, arm extend time. Sounds good. And our arm extend time was, 1 second was good. I'm going to go just a little bit more. I'm going to do 1.1 seconds because you really want to make sure it gets all the way extended. And it is okay to run the motor a little bit after you hit the stop for a little bit longer. So, and if you tested yours, if your arm did not extend all the way, you should be changing the number, running the code again until you have a good number where your arm does extend all the way. And remember too, we increased our arm output power last time. It did kind of slam in pretty hard. It was a little scary when it just extended there. So if you think it's going too fast for you, just decrease this time. And then you can make some other adjustments. All right, so we have our move only time, our extend time. What else are we going to need? We are going to need to spit the cube out next. So we're going to end up having another static final double. And this is going to be our auto, I don't know, throw time. Let's call it throw time to release our game piece equals. And I have no idea what this is going to be. Let's start at 1 second and see how much too long or not long enough that is. All right. And, there is one more thing that we should put up here. Actually, I'm going to put this up at the beginning or after the move only time. I'm going to do static final double. And this is going to be our auto drive speed. So we can just come in here and change the speed if we want to change the speed. And it will change it for all our auto modes, not just one at a time. And our speed was -0.25 was the speed that we were choosing to drive. OK, so I think that's all the ones we used so far. Let's now integrate these constants back into our code. So we're going to scroll down. We are going to look at autonomousPeriodic. Find yourself autonomousPeriodic. And for k-move only, our elapsed time here, our 2.5 seconds, is no longer 2.5 seconds. This is our move only time. Probably should have been auto move only time, but too late. We named it. It's now move only time. And our speed that we move back here, this -2.5 on set drive motors, that should be auto drive speed. And this is important because our auto drive speed, we're also going to use in our cone and cube auto modes that we're doing. And now, if we put -0.25 here and put -0.25 down here, and then maybe your drives are a little bit different. So you have a different one, like for on the short side and the long side. So now you have a short side drive and a long side drive, right, where you have to go farther to get out of the community. Now all of a sudden you have the same drive speed in 3 different places in your code, maybe 4 different places in your code. And one day you're going to be like, hey, you know what? Actually, we need to drive a little bit faster. Our auto mode is getting too close to the limit. We want to drive a little bit faster. Now you have to find everywhere you put that speed and change it. Whereas with the constant, we just have to go to the top of the code and change one number. All right, let's go down to if elapsed time is less than 1 second. This is not 1 second anymore. This is going to be our arm extend time. Yep, arm extend time. And then we already created our next one. So right now, this autonomous mode is 2 steps. Extend the arm for, I think we changed it to 1.1 seconds. And actually, I think if you hover your mouse over arm extend time, it tells you it is equal to 1.1. So that's a good way to check what your values are. Like I can see arm output power is 0.5. Okay, so our arm extend time is 1.1 seconds. So that's step 1, is we extend the arm for 1.1 seconds. Step 2 right now is turn off. We need to create a new step 2 and turn everything off step 3. So after this if, right, we have the open and close curly brace for the if, the line above the else, we're going to hit enter. And we're going to do an else if. And that else if is, well, if our elapsed time is less than, and here's the thing. This second section that we're doing is to spit out the cube or the cone, whatever it is. It's to throw our game piece. We can't just put, if it's less than, what do we call that? Our auto throw time. We can't just put this. And the reason why we can't just put this is because this does not take into account the fact that our stopwatch is already at some number. Like we never reset the stopwatch, right? So the stopwatch starts when auto mode starts, and our elapsed time is the time that we've been in auto mode. But we've already been in auto mode. If we get to this step, we've already been in auto mode 1.1 seconds. So really what we want is this next one should be if our elapsed time is less than 1.1 seconds plus however long we want to throw the thing. So down here, we're going to do arm extend. Let me get a space in there so it extend time plus auto throw time. So now, right, for the first 1.1 seconds, which is arm extend time, we do this. Then as soon as we get to 1.101 seconds, we move on to this step, and we do that until 1.1 plus, and our auto throw time, what do we pick, a second? So this is, I could just hover over it instead of scrolling up. There we go, 1 second. So this now says until 2.1 seconds of auto mode has passed. We're going to hang out inside here. Make sure you get your open and close curly brace. When you do the open one, you get the closed one. So we stay here for 1 second after this one is done. So we always are going to just keep adding to this. The next time we do this, it's going to be auto extend time plus auto throw time plus we're going to retract the arm. Okay. And what do we do when we want to throw stuff in auto mode? Well, it's pretty straightforward, right? We just have to turn on our intake and spit stuff out. And spit stuff out. That's it. So first thing is set drive motors. We're always going to do this in order. And drive motor should be 0.0 and 0.0 because we are not moving and we are not turning. Next, set arm motor. Arm motor should be 0. Because we are not moving the arm. The arm's already in position. Next one should be set intake motor. And the intake motor, now we want to do something with it. And what value do we want the intake motor to have? Well, this is the one that it's a little tricky, right? But remember in our autonomousInit, we chose our auto intake power based on whether we were going to be spitting out a cone or spitting out a cube. So really, it's just this auto intake power that we're always going to use. That is always the power we need to spit out the object. So down here, we're going to do auto intake power, set intake motor to auto intake power. And the current limit should not be arm current limit. It should be intake current limit. Okay, so now we should have 2 steps. This should work. We should extend the arm for 1.1 seconds. We should spit out a game piece for 1 second, and then we should stop moving. So let's hit the 3 dots. Let's build this. And deploy it. All right. going to close that down. Now, there are two things that we're going to be checking for here. We're going to check cube immobility to make sure the arm goes out and it spits the cube out. And then we're going to check cone immobility because it should then spit out the cone. So we have the cube in the robot already, so we don't have to change that. And we don't have to move the robot. We're basically ready to run this. So let's make sure we have everything set up. We are going to make sure cube immobility, we're on autonomous. So I'm going to enable it, and what should happen is the arm should extend, and the cube should spit out. And what we're looking for is, do the rollers keep spinning for a long time after the cube is already spit out? Because then we're wasting time. We can shrink that auto time. Or does the cube not spit out all the way, in which case we need to increase that time. All right, let's do this in 3, 2, 1. I would say that that roller spit the cube out very fast and then kept spinning for a while. So we can probably reduce that time. I am going to plug in a gamepad, though. And I'm going to disable the robot. I'm going to go to the joystick tab here and rescan. Sometimes if you hit rescan, it makes it pop up. And right now, I only want this to be controller 1. So I'm going to drag this down to controller 1 because that's what controls the arm. And then I'm going to go to teleoperated enable. And I'm going to use the button to tuck the arm back in. Because that seems easier than me standing up there and pushing it by hand. All right, so disable. Back to autonomous, so we're ready for next one. I'm going to make sure we stay on the line. This is especially important for this one because if we don't stay on the line, there's a chance that I smash the arm into the table here, or in your case, you smash it into the goal. But what we want to do now is let's preload with a cone instead of with a cube. Again, you got to kind of figure out how to do this when the robot is in this position. But I think, again, the best way is the cube. You can kind of bend around the corner here. So I think I can just keep rolling it in. And we do have to pull the arm out a little bit so it goes on top of the thing that it's sitting on. And we kind of want to shove the cone in. I think we want to shove it in as far as we can. OK, so just really get it all the way in there. And I think there's like a trick here. Probably if I bend the cone out, maybe it stays in position a little bit better. No, it's going to come out to where it wants to anyway. So that is where it's going to be. OK. And we're going to see, maybe this will hit the table on the way up. I don't know. But on our smart dashboard, we need to switch our auto mode. Because right now we're set up to do cube immobility. And we want to test the cone now because it should know, right, in our autonomousInit, it should be like, oh, it's cone now. So we should spin the intake the opposite direction to spit the cone out. All right, let's try it with cone and mobility. And we're going to go autonomous mode. And then we're going to enable the robot. So we're going to see it in 3, 2, 1. OK. So there might have been a ruler in the way, a tape measure in the way. But that worked. It spit the cone out. So we've now tested and verified that cone and cube, both of them are working correctly. It's making that switch in our autoinit. And then we also have kind of figured out that our time is probably too long. 1 second is probably longer than it needs to spit that stuff out. So I'm going to go teleop, enable. I'm going to tuck this arm back in. OK, then I'm going to disable. I'll go back to autonomous mode, and I'm going to check out the robot, make sure it is on the line. I'm going to go ahead and, well, that tape measure is just gone. I'm going to move this peg so we don't, impale anything. And I'm going to put the cube back in. All right, looks good. And then let's go back to our code, and let's adjust our time. So that felt to me like it was, I don't know, maybe 3 times too long. I'm not sure. Let's try. So we're going to go up to the top, right, where all of our constants are. And we're going to change our auto throw time from 1 second down to, let's do I don't know. Let's do 0.5. Let's do 0.5. OK, and then we're just going to build the robot code. And then we'll deploy it, and we'll basically test again. But remember, we have to test for both the cone and the cube every time because we don't know actually which one takes longer to spit out. All right, and deploy it. So it is deploying, and we are set up with the cube. So we'll check the cube first. All right. So I am on cube and mobility on my smart dashboard. I'm on autonomous, and I am ready to run this. So we're going to enable. OK. That was still probably too long, but it wasn't like way too long. All right, I'm going to go teleop, and I am going to bring the arm back in, teleop and enable. Then I'll bring the arm back in, disable. Let's put a cone in again and see if the cone spits out. All right, and the cone doesn't really like to stay up very well. Maybe you'll have to find a trick on your robot to make that happen. Worst case scenario, though, it rests on the cross beam down here, the crossbar, and so it still doesn't fall out. All right. So now we are on cone and mobility on the smart dashboard, and we're on autonomous, and I'm going to enable it. OK, so the cone falls out. The cone falls out even more than the cube. OK, cool. Let's disable. Let's go teleop. Let's enable. Let's fold the arm in. Let's disable. Let's go back to our code. I think probably that 0.5 is a little bit longer than it needs to be. Let's just lower it down to like 0.4 and call it good. We're going to move on to the next step now. And because we've kind of tuned this value in, if as we're running the other steps, we're like, oh, OK, the roller's still a little bit long, we can continue to change this number down if we want. Or if it ever doesn't spit something out, we know to immediately come back here and increase that number back to 0.5. OK, scrolling back down, all the way back down to autonomous. That's teleop. I went past autonomous. All right, here we go. Find your cone and cube auto mode in the else case here. So we have extend the arm. And then we have spit out the thing. Our next step, which get above the else and hit enter. We're going to do another else if. The next step is going to be retract the arm. We got to put the arm back in, right? OK, cool. And in this case, it's going to be if the elapsed time is less than. And we need to put all of our previous times in. So arm extend time plus auto throw time. And then plus, well, how long does it take the arm to retract? It should be basically the same amount of time that it took the arm to extend. So let's just use arm extend time again. If anything, going this way, I don't know, gravity helps it at the beginning going out, and then gravity helps it at the beginning coming. I think it's going to be the same. It's close enough to the same that we can just pretend it's the same. All right. And what should happen when we retract the arm? And actually, let me go through and let's make some notes. So this first step here, I'm going to do // So this first step was extend the arm. And you can kind of tell that's what it is because it has arm extend time. Then here it is throw game piece. Then here it is retract the arm. And to retract the arm, we basically want to go, if we go to the first case here, where we have extend arm, those 3 lines of code are perfect for us. So copy those 3 lines. Let's put them down here. And the only difference is our arm output. If positive makes the arm go out, we need to make this negative to retract the arm back in. That's it. We don't have to add anything else. OK. Looks good, looks good. Yeah, let's do it. 3 dots, build the robot code. I'm going to do a cube because the cube is more fun to put in the robot. So while this is building, I'm going to feed a cube into the robot over here. And then we'll come back and we'll hit deploy. And while it's deploying, I'm going to actually just make sure the robot is in the starting place and hasn't moved. It's probably more efficient to do that than to sit here and stare at it. OK, we're ready to go. Pop up our stuff. I want cube because we're going to spit out a cube. So on the smart dashboard, I got cube and mobility. I got autonomous mode selected. And so this time, what should we see? We should see the arm extend. spit out the cube, but it should be slightly less time, so maybe it runs slightly less too long. Then it should retract the arm, and that should be the end of the auto mode. Let's try it. Extend, spit, retract. Oh my god, that's so good. That's so good. It was perfect. And I didn't feel like the roller was too short. It felt about right. So I'm going to leave it at 0.4. You can try to tune yours a little bit more. But that was good enough for me. Okay, back to our code. What is next? Extend, score the game piece, retract. The last thing we have to do is drive. And we already kind of know how to do that because we did that in our previous auto mode. But we'll do it from scratch. Find the else case here. Hit enter on the else case. We're going to have one more else if. And this time, it's still going to be elapsed time. Elapsed time. And if our elapsed time is less than, now, look, I'm going to copy the previous one because I don't want to type all that again. But we need to take all of our previous times and put them in here. And then we need to add one more time. And this is our, I don't know. I guess we'll just call this one auto. I guess we'll just call this one auto drive time maybe. That seems kind of reasonable. Yeah. So we have the drive only time, which is for the drive only auto, and this one would be auto drive time, which doesn't exist yet, right? Because we have to go back up to the top where all of our constants are, our auto mode constants. So we have right here, we'll hit enter, static final double, G final, static final double, auto drive, and it's there, drive time, equals. And how long do we want to drive for? Well, if you think that your robot is going to always start on the short side of the field, then you can kind of use the drive time that we figured before, our move only time, which was 2.5. If, however, we think we're going to start on the long side of the field where we have to clear the farther out zone, then we're going to have to drive farther. So in this case, I guess let's try to do the drive farther one because that should make it safe for you to use this auto mode on either side. So we're going to start with an auto drive time of, so 2.5 was not quite far enough. Let's go with like 3.5 as our first guess. I don't know. We'll see how it works. Remember, though, in auto mode, if you drive across the middle line of the field, that's a penalty. And if you drive even farther across the line and you hit the game pieces on the other side, that's an extra penalty. So we definitely don't want to drive too far. Okay. So we'll start with 3.5. Let's scroll back down in the code. We're going back to autonomousPeriodic. Find autonomousPeriodic. Find where we left off, which was now our next one is we have all of our previous times, and we're adding on our auto drive time. And we want to drive. So if we want to drive, what we have to do is we have to set our drive motors. We're going to set our drive motors to, well, this is going to be auto drive speed. Auto drive speed. And do we want to turn it all? No, I don't think so. We're going to go straight back. And then what else do we need? Well, set arm motor. Are we going to move the arm at all? Nope, so that's a 0.0. Set intake motor. Are we going to move the intake? No, so that's a 0.0. And again, it always chooses arm current limit, but I'm going to change that to intake current limit. All right, so now we should drive the distance we want to drive, and then it should stop. Okay, I've got my marks on the line. We can load this cube up and give it a try. All right, so build the code again. And of course, while the code is building, I don't have anything in the robot, so I'm going to start with the cube again. Also, the cube scares me less when it kind of throws it at the tool wall over there than the cone. So let's get this in here. All right, looks like I'm ready now to hit deploy robot code. We are deploying. And then, yeah, I will take a second to make sure my robot is exactly where I want it to be on the starting position. All right, and we're ready to go. So make sure we are on cube and mobility. Make sure we are on autonomous. And this time we're driving farther than before. You can't see this, of course, but we are driving right at the expensive camera equipment. So instead of kind of being out here and watching what's going on, I'm going to make sure we don't crash. So after I click enable, I'm going to get ready to click disable if the robot drives too far. So let's do this. In 3, 2, 1, go. Arm extends, cube's out, and we start driving. And we start driving, and okay, all right. I was about to get scared, but okay, so the line is here. That's a little bit too close for comfort. That might be over the line. That might not be over the line. And we don't want to leave that up to the refs. We don't want to stop here. We want to get to somewhere like here and stop. So we're going to bring this back and reset it. And then we'll just increase that drive time a little bit, and we should be good to go. Oh, that brake mode. I guess I could have enabled the robot and driven it back, but even if you're driving the robot in position, make sure this last little bit of lining it up, you are doing like by hand, not by just trying to drive the robot in place. That is not a time to get lazy. The starting position must be exactly the same every time. All right, cube is in. I'm going to disable the robot. I should have disabled the robot before moving it, but it was on the do nothing section. All right, so in our code, we don't have to do anything down here in autonomous periodic. We just have to scroll up to the top where our constants are. And the only thing we have to change is drive time. And we need to make drive time just be a little bit more. I think I'm going to make drive time be 3.8? 3.75. 3.75. And that is the only change we have to do. So let's hit the 3 dots. Let's build it. Hit the 3 dots. Let's deploy it. Open up our stuff, make sure we're still on cube because I put a cube in the robot, autonomous. All right, and we can enable this in 3, 2, 1, go. All right, and as it backs up, I'm still ready to disable if I need to. And I did not need to. All right, is that good enough? If I like get on the line and look down the line, I would say that we're clear. I would say that's pretty good. I would maybe do just a tiny bit more because if maybe you bumped into something a little bit, like we definitely don't want to. I'm going to disable the robot this time because it's the safe thing to do. It's the smart thing to do. We want to go a little bit farther because we don't want to take a chance at not getting our mobility points. So I think maybe a little bit, another 6 inches, and I'm comfortable. So I am back in the starting spot. This time, though, I'm going to put a cone in it because we're going to run the auto mode one more time. We might as well see it happen with a cone, too. So the cone is in there. I'll move the cube out of the way. All right, and back to the code. The only thing we're going to do is change that drive time by a little bit. So it's 3.75. Let's do 3.85. So 1 more tenth of a second. And hit the 3 dots. We are going to build the robot code. Then 3 dots and deploy it. All right, bringing up our driver station here. I want to switch to cone and mobility because I put a cone in the robot. And there are some other things you can do on this smart dashboard. Like you could put pictures on here. I think you can add more things to it. So you can experiment with that. You could put a picture of a cone next to your cone one, a cube next to your cube one. Just make sure your drivers know, your field crew knows to click the right thing and how to click the right thing. All right, we're on autonomous. We are going to enable it, so it should extend and spit this cone out. And then we should get just a little bit farther past the line. Oh, that's perfect. That's where I want to be. Yep. So the line is right here. We are now, I would say, a good, foot and a half, almost 2 feet past the line. Nowhere close to crossing the auto mode, the middle line in auto mode. So nowhere close to those penalties. And I mean, that right there, we scored what? We would have scored a piece high, which is worth 5 points plus 1 extra point in autonomous mode. I did disable the robot. And we got the mobility bonus. So that's already, what, I think 3 points for that? That's 9 points already. All right. Actually, that is it. That was the last bit of that program that we needed to do. So we have a successful auto mode going on here. Okay, so we have finished the autonomous mode programs that we were trying to get done. We have 4 autonomous programs that are all usable. Well, I guess the first one, which is do nothing, is technically usable, but why would you ever use it unless there was a problem? But we have the ability to just drive over the line to get mobility points. We have the ability to score a cone and get mobility. We have the ability to score a cube and then get the mobility points. Also, mobility is kind of a tough sentence that I thought I would share with you. All right, but there are some things that we have to think about. We did all of this testing on just our laid out field stuff. We're pretty confident that we're driving the right distance, but is the arm actually extending out and spitting the cube out so that it sits on the shelf? Or is the cube going to bounce off the shelf? I noticed with the cone too, when the cone was in the gripper, it had fallen pretty low. So when the arm swings out with the cone just barely on the end, does it clear the middle post? Does it get to the high one? Does it have enough time for it to actually sit on to spit out? So we might have to adjust our timings for the cone. Heck, we might have to actually tell the robot that if you're doing a cone auto, the first thing is suck the cone in, then extend the arm out just to make sure it's all the way up. Or maybe we have to suck the cone in while extending the arm out and then spitting it out afterwards. So those are some things that we're going to check, but the only way we can test that is if we have an actual scoring element and not, some workbenches behind. So if possible, you can build field elements yourself. There are some team instructions for how to build the different sections of the grid. You can build just a cube section, a shelf section, and a cone section. And that's pretty easy. It's going to take some wood, but you should have some leftover plywood from the bumpers or your belly pan anyway. So maybe that's one way to go. Another way to go is if I had spent some time, at least for the cube, I probably could have set up a box or cardboard boxes or something that's the right height so it would spit out at the right height and kind of have the right shaped shelf there. So that's something that you could try. For the cone, maybe if you even just had one PVC pole that you kind of held in place or you had something anchored to it, that would work for auto mode as well if you measured the distance. Another thing that's really good is reach out to other teams in your area. There's a good chance that somebody else has built some of these game elements. There are a lot of teams that build a partial field or even a full field. So they might have lots of available space for you to come and practice. And if you reach out to some of the veteran teams in your area, in my experience, they have all been happy to host rookie teams or teams that need a field to come in and practice their stuff. And that is what we are going to do. We are eventually going to take this robot over down the hall around it's a bit of a hike, but we will take this robot over to the field that is set up at the school here. 302 Lake Orion has built a field that they're going to let us use. And we'll go over there and we will test our auto mode on that field and we'll make adjustments to it as we go. And since we're over there, we'll also test out our teleoperated mode, right? We'll drive around a little bit, see what we can learn. We'll probably have to retune our arm to make sure it's at the right height and the right position to score there. So stay tuned for that in a future video. We're good for this one. So before we go, special thanks to Argosy and Everybot.